Field scoping. So a caveat, this is geared more towards culverts because that's the material that we have readily available to us. But, you know, ditches and other things like that, you know, it's pretty easy to assess if they're working well or not. So we'll have a real brief conversation on ditches maybe at the end and see what you may have to offer and what you would look for at the inception of a project to see if there are any drainage issues or hydraulic related problems. Learning outcomes. So we're going to, again, identify some more resources for you that are free, that are at your intellectual disposal. We will talk about 3 primary areas of focus for assessments, and again, mostly for culverts. Those are the big items that we want you to look at. But you can probably apply some of these principles to your ditch lines and storm drain systems and other things. And then we'll explain assessment procedures. So this is what we don't want to see happen. Inevitably, you have stuff like this, especially during floods. We don't design all of our infrastructure for a 100-year event, and even if we did, then we have these 500-year events or these 1,000-year return periods. So things like this are inevitable, but we certainly want to reduce the rate of failures. And that's one of the primary reasons why we focus a lot on assessment of our infrastructure. So it's required by law that you have an asset management plan for your bridges and pavements. Unfortunately, culverts that are less than what we would consider bridge length or bridge span, and that's that 20-foot threshold, there's no hard and fast requirement for inspection of those. Most states are developing plans for those, and it may be from 10 to 20 feet, it may be from 4 to 20 feet. They probably don't all inspect the real small ones. So what we would encourage you to do at the very bare minimum is when you have a new project coming up, walk the footprint, take at least a very brief look at all the culverts and see if you can identify any quick issues that could be addressed or maybe that indicate that you need to replace that culvert while you're doing the project. So that would be the very bare minimum level of effort that we would recommend. But hopefully you would do something more substantial than that. So with that, we're going to talk a little bit about assessment procedures. My recommendation is that you get a hold of this free manual. It was developed in conjunction with our federal lands highway divisions that Veronica used to work in, and other folks in federal highway and our consultants. So in federal government, we have what's called 508 compliance, and that means that anything that we post that's open and available to the public needs to meet very specific requirements for people with visual challenges. Unfortunately, this manual was developed before that became, you know, really a hard and fast rule that we paid very close attention to with everything. And now we cannot have it on our website. And I actually did a Google search for it a few weeks back, and I couldn't find it. So my recommendation is that I will pass the PDF file to Chase, and if that's something that you want to post for everyone's disposal, the material is perfectly sound. The technical content is fine. It's just that we can't host it because of the 508 issues. So I'll make a mental note to pass it on to you, Chase, and then if you want to send out an email to folks, just as a reminder that it's there, that would be awesome. Something else we have that is posted is this culvert pipeliner guide. So if you go out there and you do an assessment and you see some issues, and it's not to a point where you need to replace a culvert, maybe you can line it instead, and this gives you some very good information on the different types of culvert liners. It is from 2005, so the material might be a little bit dated, especially cost information. Whenever you start incorporating cost information into a document, with inflation and availability of materials and whatnot, that changes, you know, very quickly, even over the course of a couple of years. So some of that is dated, but it's still a very good reference, and we'll recommend that you check that out. You know, it's, in my mind, it's very interesting content. There are other things that are probably of lesser importance to you. We have a bridge inspector's reference manual that has a chapter on culverts. We have some other stuff in the highway, or AASHTO has some things in the highway drainage guidelines on culverts. They will be coming out, I thought it would be out by now. AASHTO will be coming out with a culvert and storm drain inspection guide. And there's a wealth of good information in there. It's meant to be a replacement for the old Federal Highway Culvert Inspection Manual back from some time in the 80s. It's a very good document. It's the result of a research project. And I don't know how it works in state with AASHTO subscriptions and if staff have ready availability to that. So it's not something I can pass on to you because there is a fee for it. But if you're interested in that, you can get a hold of me and we can talk about it. I can't get you a copy, but maybe it's something that, I don't know, maybe someone in a bridge or someplace can actually get a copy, and I don't know if you can illegally share it. I don't know. I don't know all the logistics. I'm just saying it's going to be available. I honestly, as an aside, every once in a while, for the greater good, I'll tend to bend rules a little bit, but I can only do so much. So culvert assessments. There are different kinds of assessments. If you come across something like this, there are these confined space requirements that folks have, and especially if, I myself am not necessarily very comfortable into going into very tight and dark spaces. I remember that haunted house I was telling you about the other day with the tunnel. I was freaking out there. So I'm not one to be like climbing through culverts and doing inspections. So there are different levels of inspection. And sometimes all you need to do is take a look through the inlet side and the outlet side and see if you can identify any issues. And those will be called end-only inspections. So these are especially for your 2-foot pipes, your 3-foot pipes, probably even all the way up to your 4-foot. And especially if they have flowing water in them, you're not going to go inside there. It's just not safe. So we have end-only inspections where you look in the inlet, maybe have a flashlight, can you identify like a corrosion or that rusting abrasion issues? Do you see any deformation of the barrel, joint separations, those types of things. All of those are described in detail in that manual I mentioned. And if you don't see that stuff in the inlet and outlet, then you probably say, you know what, this is probably okay. The larger structures, like larger box culverts and whatnot, you actually probably want periodically someone to go in there and take a look around. You're going to, guess what, if it's concrete, you will see cracking. But it's up to the culvert inspector to determine, is that cracking an issue or not? Okay, so we'll talk a little bit about cracking here in a couple minutes. And then if you have a smaller culvert or a high-risk situation and you really don't have an opportunity for someone to get in there, then there are different kinds of, and this is the cool stuff, these remote operated vehicles with cameras, and you can take some video, you can take some pictures, you can actually even take some measurements. They have like these laser ring profilers that can take measurements of deformation and measure crack widths and things like that. And if you like to operate remote vehicles, maybe you start to carve out a niche for you remote. And you can just go out there and play with like these remote vehicles all day and take neat pictures, and it's kind of like little monster trucks, and you can run them in the culvert. Maybe that's up your alley. Yeah, so good for this guy. Again, I'm not one to be doing that sort of thing, especially in water that's up to your waist. So this is a shout out for culvert inspections. You usually go out with at least a minimum of 2 people, just for safety reasons. So things that you typically look at as far as areas, there are three main categories: the structural condition, the soil support, and the culvert and the channel performance. So let's just touch briefly on all 3 of those. But again, for more information, we have that Federal Lands Highway Culvert Assessment Manual that Chase will be posting on the R drive. Okay. So structural condition, these are the things that we typically look for. And so Dorothy, I think you mentioned the other day about some issues within the barrel. We look for deterioration. And deterioration from the bottom up to the spring line or the wide part of the culvert. Do you see the corrosion? you see the abrasion. So abrasion is kind of like, going back to our discussion of shear stress. When you have like gravel and cobbles and stuff, it doesn't happen with sand, but this coarser bed material in your stream channel, during the higher flow events, as that moves through your barrel, it's kind of like this really coarse grit sandpapering effect. It's rubbing on the bottom of your barrel, and over a course of time, depending on what material that barrel is made of, it can wear away. It can wear away the invert. And guess what? Once you wear away the invert, instead of having flow going through your barrel, you're having flow going through your bedding and backfill, and that's a big problem. So some things we pay very close attention to that are very easy to spot. Invert deterioration, and that's usually from a combination of abrasion and corrosion. Corrosion is that rusting effect. We also want to take a look at the joints. Is there separation? If they're gasketed joints, is that rubber starting to deteriorate or pop out of there? And guess what? During initial construction, when culverts are installed, they're not always installed correctly. So that's especially, you may have joint deterioration issues and cross-section deformation. Cross-section deformation during construction can easily happen if, before there's sufficient cover over the top of your culvert, they start running the bulldozers and the track loaders and their dump trucks and things over the top of the culvert. And a lot of times, if you're not careful and if they're not careful, they can deform that culvert so that it's no longer structurally sound and has the sufficient capacity. So this is a call out that before you accept culverts at the end of your project, you at least take a quick look inside and make sure they're okay. So that's for your construction inspection step. Cracking, again, concrete cracks. We see cracking actually in high-density polyethylene pipe, slow growth cracking. Metal, I'm not even sure about metal. I don't know that that's, I honestly don't know. I haven't heard of cracking in metal as being a big source of concern. But especially with concrete, it will crack, and so you need to be concerned with how much cracking do you see, where is the cracking, and then if you notice cracking, do you have soil staining or rust staining? If you see soil staining or rust staining around the cracks, so if you see kind of like the orangey colors, that's a sign that you got a pretty serious issue, because the rust staining means that the water's reaching your reinforcing steel, and once that starts to rust, that is in itself a problem, and then it starts to cause concrete pop-outs. So your concrete can start swelling and popping out, and we'll see a quick picture of that. So when you see cracking, and if you think it's severe, and if you measure the crack width, and it's large enough to be a concern, and if it's at particular spots in the culvert that indicate a structural issue, then you want to notify someone, and you want to do some repairs before that gets too severe. Again, for the smaller culverts, you're not going to climb inside there, so you're going to take a look at the inlet and the outlet, and the outlets are typically harder to find. They're probably buried in the brush and the trees and the weeds and things, and they're not always necessarily straight across the road. So if you think, here's the road here, if I have my inlet here, the outlet's going to be there. Not necessarily. Sometimes they're skewed, so the inlet's here and the outlet's way over there, and you don't know necessarily what the slope is. So the inlet could be over, or the outlet could be over there, and it could be like 30 feet down that hill. So sometimes they're hard to find, but for the small ones, it's definitely worth taking a look. If you see something that's of concern, a critical finding, and you think it's probably especially a structural issue, and there's something going on inside, you may have to do some remote inspection as well. So that culvert assessment guide that I mentioned breaks things into categories, and what it uses is a good, fair, poor, critical rating. The ASHTO document that is coming out on culvert and storm drain inspection, they didn't like this critical one. Was it the critical one they didn't like? They use a similar rating system, but at the lower end, I think they changed the critical one. Honestly, I can't remember. But it is fairly similar, but this is a pretty good setup. And again, here's some different things that you look at. We talked about most of these. If you have some specialty materials, like, I don't know if you have wooden culverts, in national parks and national forests, especially if it's been there for 100+ years, you could have like wood culverts and whatnot. So you look for some specialty items like rot and insect infestations and things like that. And if you see an insect infestation, you call Terminex and say, hey, come out here and spray this wooden culvert for me. So the other thing is, it's important that we consider that a culvert is not just a barrel that transports water. It's actually a system. So the culvert barrel is just one component, but you have what we call these appurtenances, like your aprons on the outside, especially on the outlet. It's very common to use a concrete or riprap apron, and that helps prevent against or guard against. I've heard erosion. Did someone say erosion? Yeah, erosion, outlet scour. Sure. So you want to take a look at your aprons and your end sections. We saw yesterday a metal end section. Those come by standard for different sizes of pipes. Look for that kind of stuff. Your head walls, your wing walls, are they in good condition? So those are other parts of the actual structural culvert that you're going to look at and assess their condition as well. All right, so here's some pictures, and again, if you go to that manual that I referred to, there are a lot more pictures in there. But what we see here, this is pretty severe invert deterioration. And if we assume the flow is going this direction, I'm not exactly sure, but let's assume it's going that direction. Where's the water going?
Soil.
It's going down through the bedding. Yeah, it's going down through the soil, and it will eventually do what we call piping. So it will develop a channel on the outside of the culvert, and will start to eat away your embankment, and that's just a huge problem. So piping can occur through the bedding material. If you have some perforations in your barrel or some poor compaction techniques, piping can occur along the sides and along the top as well. And the bottom, the big picture idea again is it's nice if we have the water going through the culvert and not through the embankment, right? Water going through the embankment is just not good. Corrosion and abrasion typically work together. So this, you see some mild, actually invert rusting here, and then we probably had some additional abrasion too, and that's from that coarser material going through the culvert, kind of like sandpapering it. This is pretty severe corrosion here. This thing here, there's nothing you can do with this as far as lining or repair. This is severe cross-sectional deformation. You're going to have your embankment start to leach out into your barrel and go down through here. Looks like the invert's gone. You just need to replace this ASAP. This is, I'm not even sure if this is critical. This is probably close to being a failed condition depending on what the roadway up top looks like. So that's the general idea of culvert assessments. You want to catch things before they get to this point. And once they get to this point, you're out of options except for an emergency replacement. And that's just not a good position for anyone to be in. All right, so this, and I'm pretty sure this is Scott.
Hogan?
Yeah, I'm pretty sure this is Scott Veronica, so that's one of our colleagues. He actually stood here for 3 days. This gives you an idea of the level of his dedication. He stood there for 3 days holding that culvert up until it could be repaired. It was amazing. He was so tired. His arms were so tired.
He was mimicking Leonardo da Vinci.
Exactly. As an aside, okay. I have to embrace my silly side. As an aside, if you're out in the field and you see something really cool, do your best to get a dramatic picture. And especially, something along these lines where it looks like you're in mortal jeopardy. Because then you send that out to people, and then when you retire like 20 years later, it's amazing because they'll put that in your picture collage, and you'll say, oh, I remember doing that, that was so cool. So get those dramatic pictures when you're out there in the field. So where's the water going here? It's going down, and it looks like a lot of the bedding, at least right through here, is no longer there. And that culvert, if it were left like that, probably within a very short time period, would fail structurally, and you would have a roadway failure too, and a roadway closure. I think this is one I believe they actually did a structural lining on, the invert lining. All right, so again, we said look beyond the barrel. And so here you see a wing wall that's falling off, and then what does that lead to? You maybe have some loss of your embankment that wing wall was protecting and supporting. And it's kind of like a domino effect. Once you start losing the embankment, that propagates up to your shoulder or whatnot. It can be just a huge issue. Here you call terminus for this one. What do you think happened down here?
Maybe somebody crashed into it, or
So it's not a result of crashing. I'd like to guess.
Mowers.
It's the mowers.
mowers.
Mowers?
I think that's mowing.
That's another good
They're all
guess,
right
but
on.
it's not a result of mowing.
A really strong flow
Rock tree
for
lawn.
a long time.
You're getting closer.
Like what?
It is a result of some water action. All right.
Debris going through it.
It's not winter-based. You're getting warmer. Getting warmer. All right.
Flooding.
All right. So let's go back to yesterday or the day before. This is what happens when you get to be get too many things on your mind. You can't remember the day when you talk about what. So yesterday or the day before, we talked about diving in the deep end of the swimming pool, right? Actually, I think this was on Tuesday. So you're going down there and you're trying to swim down to the bottom to retrieve that silver dollar or whatever. And the further down you go, the more you experience the water pressure, right? Well, guess what? If this was minor to the fill slope, and it probably was, so they cut it like this and just left it like that, how much strength do you think this edge has here? Not very much. This becomes kind of flimsy, right? And then if you start to build up some head on that, some water pressure, and that hydrostatic pressure starts to push in on those, it can squeeze that in pretty easily and just bend it and crumple it out. What do you think the hydraulic efficiency of this is now? It's poor. Yeah, it's very poor, which leads to what? Greater water depths, because the water's having more and more difficulty getting into there. And then the greater water depth leads to more crushing, and then probably some buoyancy where it can like push that thing and crumple it up, right? And it just keeps on going and going and going until eventually you're not getting enough water in the culvert, and maybe you have roadway overtopping, or you're losing your embankment, or other kinds of things. Yeah, so that's exactly what happened there. It's water pressure.
Can you, I guess, dumb question, can you still get both kinds of flow through that, or does it affect it enough? Like, I mean, can you get weir flow and orifice flow out of that, depending on if it's full or not?
This condition here, you're still going to get some flow through there,
Right.
but it's going to build up additional headwater to try to push the water through there.
Right.
And then like I say, the additional head will then crumple it some more, so it'll build up more head to push through there. And eventually, it probably, if it goes along long enough, it will just crumple that so it's hardly getting any water in there, and it'll look to
But
go
so you'll get a constricted flow through the opening, and then once it gets into the pipe, it'll spread out, so you'll never have full pipe flow, or you could.
You won't have a pipe.
But yeah.
Eventually, you just won't have a pipe because it'll just crush it, and then it'll start overtopping the road, and you want to go over. So the moral of the story is look for this kind of stuff, and now you know why that may have occurred. If you're going to do the taper to the fill slope kind of end treatment in the culverts, you anchor it into slope paving, the concrete slope paving, and that will guard against that. Or else you don't use the taper to fill slope, you put your culvert in a head wall. All right, cracking. Yeah, like we said, concrete cracks. If you see cracking, it's not necessarily an issue. You don't know. So you look for where is it at, how wide is it, how extensive is it, and do you see signs of soil or rust, those sorts of things. For metal culverts and plastic culverts, you want to look for pitting and denting and things like that. And for masonry, I don't know if you have masonry culverts, but there are things to look for as far as masonry goes. That's again more historic, and actually in your urban centers you may see some of these. So I don't know if they would have them in St. Louis and Kansas City. We actually have them in Baltimore. more for, stormwater and whatnot. But we have, I think I probably have on my hard drive some very elaborate pictures of like these huge brick culvert arches like underneath the city. And they're starting to fail. So if you drive on some of the Baltimore streets, you almost need like an all-terrain vehicle. I'm serious, because the rutting and stuff can be like this deep. And you see where these things are starting to get crunched and failing. But some of these are like, probably 8 or 10 feet high. They're amazing. They did some really good craftsmanship back in the day. I'm always impressed. Yeah, that's just a brief overview of structural condition, but again, there's more detail in that manual. We also need to look for signs of soil issues. And so we're going to look at the inlet, the channel on the inlet side, the channel on the outlet side, the embankments, and that sort of thing. And so what you see here, of course, is, well, it's scour. It's outlet scour. And what you see here also is,
That culvert is holding up pretty well, I'm just saying.
well, I would agree, yeah.
Nice timing board.
Yeah.
So that's kind of what I was getting at. What you see here is perfect opportunity for a picture that will then get circulated around, and people will see how cool hydraulics is and how cool you are, and then it gets into your retirement collage. That's all I'm saying.
A picture of you jumping off that, acting like you're diving in the water's only
No,
about
seriously,
3
wouldn't that be
inches.
awesome though, if you're like in your like saying, I'm not saying to do this. I'm just saying, wouldn't it be cool if you were like jumping off and you're in midair like this, and someone like snaps that picture? I mean, it would suck afterwards for a little while and you land in that gook, but I'm just saying that would make for a very cool picture.
Can you tell if that was done after? Can you tell if that was done after one major event or is over multiple events?
Well, so I would, so that's a good question. Did this happen as a result of lots of events or after one major event? So for me to have an educated guess, I would have to look at the material. So what do you see here? You see a vertical bank, right? Non-cohesive soil, sands and gravels cannot hold a vertical bank. They have a certain angle of repose. Given that this is a vertical bank, I would say that that's a clay type material and probably has some very good clay content. It is really cohesive. And so what we know about cohesive soils is they will ultimately erode mostly to the same depth and whatnot as non-cohesives, but it takes a lot longer. The process of erosion and cohesives takes a lot longer. And we know if, these, especially in kind of like this arid setting, flash floods happen, but you don't get rain for long, long periods of time. So I would speculate, given all of that, kind of like doing my Sherlock Holmes kind of thing, I would speculate this probably occurred over multiple events, maybe over years, and what wasn't happening here, no one was checking it yet. And that's to say if this is actually just all outlet scour. The other thing we don't have is a picture of the downstream channel. So we know that we can have local erosional issues, and we can have erosional issues over a long reach of channel as well. So how that could occur is that you start building all these Walmarts and other things, and you don't have a good stormwater management. Going back to Veronica's discussion on Tuesday, you have a lot more runoff. Once that water gets in that channel, that channel needs to reach a new state of equilibrium for that increased flow, and it's going to start to incise. We don't know if anything like that's going on. I would say probably, I don't know, maybe not. This seems to be more like a scour issue to me, but we would need to see what's going on in the downstream channel to get a better idea. And then probably what's going on in the watershed too. Has there been a lot of development?
Could something like that happen also if it was like near a dam or somewhere where the water level was rising and then lowering instead of rain? I mean, it could maybe not be attributed to rainfall at all, just by saturated soil and then unsaturated soil back and forth over and over again.
So this is cool. And I'll go off on a little bit of a tangent just for a minute. What I find more fascinating than, Let's be honest. Roadway drainage is okay. I mean, it's okay. You gotta do it, and it's important. It's important to the integrity of the road. But my personal feeling is it doesn't give me a sense of like super excitement, you know? It is what it is, it's critical, you take care of it, but you may not necessarily get all passionate about it. What's really cool in my mind, for me personally, is, you know, the river, what we call fluvial geomorphology, how rivers change with flow, with slope, with their physiographic setting, with the soils, and how they change based on, you know, these people-made structures and interactions and things like that. That stuff's really cool. So if we build a dam, if we build that Walmart, if we have Las Vegas, the Las Vegas wash drains into Lake Mead, then you have years and years of drought, and the reservoir level drops. And what does that cause? Instabilities all the way back up the wash, where you get like 40, 50, 60 feet of incision. And it's really actually happening. So those kind of things are kind of cool. So yeah, all of these wrap together. So, you know, the moral of the story is, when we see stuff like this, it could be a local issue, or it could be partially or maybe mostly attributed to a system-wide issue, but we don't know unless we look beyond the culvert. What's going on up and downstream, what's going on to the left and right, what's going on in the watershed. Okay, so we can't always assume that there's one specific cause for this unless we take a holistic look and see how everything has been changing.
Could this also have been from like a drought, like there was water all the way up there and then the water level kept dropping? And then, so since it was dropping, the water was dropping out of the culvert and doing the scour underneath and then continuing to go down?
So I think the way a drought could affect this stuff, there's probably multiple ways, but one of them would be kind of like that. We talked about tailwater and how important tailwater is for culvert hydraulic analysis. So if the tailwater level is controlled from something downstream, like again, a lake or reservoir, and that lake or reservoir level drops, and then the tailwater here drops, and we have a greater energy slope, so it's not channel slope initially, it's more energy slope, and there's more energy, there's more attractive force, there's more velocity, there's more potential to pick up and transport sediment downstream. That would be one way that a drought could impact this. Another way a drought could impact this, and there's probably, I would say, maybe 10 ways or more. Another way a drought could impact the stability here is that it could kill off the vegetation. Maybe you have lower groundwater levels, the riparian vegetation is not getting enough water, maybe it dies off, and that vegetation was contributing greatly to the stability of the banks. And so maybe those start to erode and other things happen. So yeah, actually, I think it's fascinating, but there are lots of ways that these interactions can happen. So there's lots of ways that a drought could impact something, or too much rain, or, you know.
Is this type of scour just, would just be related to the outlet side? Or could you see something like this on the
Yeah,
inside?
so that's a good question. So do we typically just see scour at the outlet, or can we also have erosional issues at the inlet? If this next slide is to that point, I will actually be amazed. I'm not sure if it is or not, so let's see. It's not. I do have one coming up. So we're going to address that question here in just a second. Yeah, it's a few down the road, but yeah, well, let's talk about soil issues at the inlet side here in a minute. All right, so again, this probably wasn't being assessed or inspected on a regular basis because it's not, you know, the span doesn't meet the requirement to have the biennial inspections because it's, you know, if this were wide enough, it would be considered a bridge-like structure and would be required to be inspected. But you need to do that. Voids. So again, going on with soil issues, you don't necessarily just look at the outlet or the inlet to see if you have erosional issues. Some things you can see from the roadway surface, unfortunately. And that's the worst, one of the worst case scenarios. When you start to see the issues at the roadway surface, that means that the integrity of all of that backfill over your culvert is probably in question, right? Thankfully, this was concrete, so it's kind of spanning the issue, and it didn't have like this dramatic failure all at once. And also, fortunately, it was off in the shoulder, but you know, these things will happen. I can't say that these two pictures are related, but this could potentially result from this. What you see here is deformation and a lot of joint separation, and here's that soil wedge. The soil, with the flow going through the culvert, this soil gets washed out and downstream, and your embankment just keeps on coming down through here and getting washed out. So this could result in this. So again, if you're inspecting for that, every once in a while, especially if you see those dents and perforations in your corrugated metal, or if you see joint separation, or if you see these ginormous soil stained cracks in your concrete culverts, you want to do some testing and see if there are some voids on the outside of your culvert anywhere along here. Veronica, do you remember where you got this picture?
Caltrans.
This is Caltrans. This is one of the coolest pictures I think I've seen as far as soil piping, because what you have is you probably had some issue here with the joints or perforations or something went on. Poor compaction practices, maybe.
Actually, Caltrans now requires in their bigger culverts that they actually test it, go in there and test with that hammer, and they listen for the sound. If the sound changes, they know they have a problem, and that's how they found that big void.
Very interesting. Yeah, so this is the soil piping. This is the water forming in the channel on the outside of your culvert and carrying that material away. With these flexible culverts, so flexible culverts are your corrugated metal, your plastics. They rely mostly on the surrounding soil for the structural support. They kind of like form the tunnel for the water, but that soil is providing a lot of that structural support. And if it's not in there, that corrugated metal or that plastic will have a tough time supporting all the remaining loads. Okay. And if you don't catch it in time, these are things that can happen. If you don't do proper inspection during construction and make sure they're doing using quality bedding and backfill according to your specifications, and if they're not doing the proper compaction, and if you have joint separations or other things going on during construction, you know, these types of things can happen. It looks like 3 culverts, but actually there's only 2 culverts and one huge soil pipe right here. All right, just another example. We actually use, these 2 are from the culvert course, and most people now actually catch this. There's actually a guy in there. And why there's a guy in there, I don't know. I would applaud it if this is that instance where he's saying this would make a cool picture that I can show everybody where I applaud that 100%. That's exactly what should happen, as long as you're safe. But you know, is this kind of like a hermit, or is this kind of like, since it's kind of grainy, I almost wonder, is this like another Bigfoot sighting? I just don't know. I just don't know. I'm not making a link to Bigfoot and culvert failures, but I'm not ruling it out. Another cool picture. It's unfortunate that these things can happen. That is a good looking picture.
Up in Maine?
No, in Missouri, there was a couple of years ago, their study actually captured the whole thing, just completely collapsed.
Yeah. There's another one up in Maine, and the journalist had it.
What are you looking at?
Caught the whole thing. When he brought it up, he caught the whole thing. It's amazing.
You know, honestly, I don't know how this was fabricated and installed. These would be wraps, most likely around where you have the bell end of the next one down, hooking into the flat end of this, I would think. And maybe they wrap that actually to provide protection against soil infiltration, is my guess. It's just a standard practice that they use. And the joints actually, to me, just from the outside, still look pretty good. So what happened here, who knows? I don't.
Huge flood.
All right. So other soil issues, it's not necessarily just the water going through the actual culvert, right? It could be water cascading down from your roadway. So we talked about the importance of good ditch design, curb and gutter design, and if we don't pay careful attention to that and make sure we have sufficient capacity, we could have issues with water coming off the roadway and eroding around, eroding our embankments, eroding around our infrastructure. Nicely done. Nicely done. Look at that. On that left there, top, the left and then the right on the top there. That's what you want, right? I mean, this guy right here, actually his full foot, his full right foot is not even on there. He's leaving his heel dangle over the edge. That's just good work. All right, so here's just some outlet scour issues that we already talked about. This is extreme. And you know what? The other issue that you run into with these things, if you're in a high-value stream, especially with endangered species, endangered fish, or things that our resource agencies are pointing out, how passable is something like that? It's not. And if you're looking to replace that or do something different, how are you going to address the drop in grade from up here all the way down here? That's going to be a lot of work to make sure that you have sufficient grade for your species to get back up through here. And that just goes to show outlet scour, like we saw in that one picture with the concrete culvert. If it gets too out of control, it can also undermine your culverts. All right, so here's what we were talking about hydrostatic pressure and buoyancy forces before. So here's a quiz for you. What condition do you think, what control type do you think this culvert was in before it had this issue? Inlet or outlet control? And why? So I'm not going to allow you to just guess one or the other. I need a why following that.
Because there was uneven hydrostatic pressure within the barrel. If it was fully submerged, the pressure on the outside of the barrel and the inside of the barrel would be equivalent. But because there's a lot of pressure head on the outside of the barrel and there's not much pressure on the inside because there's only a supercritical flow, only a small amount of water is filling the pipe, it's just pressing in on the inlets.
It goes buoyancy force.
I think
That's 100% correct.
Woo!
What color star did Nick have before?
Platinum.
What's after platinum?
Double platinum. Double platinum.
Double platinum? What's even fancier than double platinum? Is it like that? Is
Diamond.
titanium better or is it worse than
Gold
platinum?
record.
Gold record platinum? Yeah, so, yeah, what Nick said is exactly right. So we remember that in inlet control, we have a lot of unused space in our culvert, right? Because it's flowing supercritical. So, you know, maybe in this barrel here, let's just say maybe the water level was up here. If this inlet becomes submerged, we know that this is also the least hydraulically efficient inlet type. As this becomes more and more submerged, we have a lot of air still in the barrel, so we're displacing a lot of water. When we displace water, that's that buoyancy force, and that's going to start, and it just jacks it and jacks it and jacks it, and then you also have the momentum of the water possibly coming in. Although if it's high head water, you're not going to have a lot of momentum. But that buoyancy force, and look how long this has been projected. I mean, it's what, like maybe 30 feet out here, which is just crazy. I mean, why would, that seems like a total waste of material. That's too much cost. But yeah, that buoyancy force just, and the bending moment is much greater all the way out here because your hinge is right here, so that bending moment just wants to force that thing up this way. You still would have had issues if this were cut off possibly, but the bending moment is great because this is so long, right? bending moment being that force times, the buoyancy force times the distance to that hinge. So moral of the story, for your, use your head walls where you need them. Realizing that thin edge projecting is not necessarily bad, but you need to do the hydraulic analysis to make sure you won't have issues. But I think in federal lands, do they use head walls automatically for 4 foot and greater, or is it even less?
Greater than 4 feet.
Greater than 4 feet, yeah.
Yeah, I just wanted to say, one project I worked on in California, they had a 8-foot, no, it was a 10-foot corrugated metal pipe, and it had a head wall on a 30-degree slope. And the water going in was probably about 8 or 9 CFS. And we went down to the bottom of this huge slope. It was probably 150 feet long. We walked all the way down there, and there was water coming out, so we thought it was fine. But then we started doing a little more research, and what we found out was that in the middle of the pipe, the bottom was eroded away, it was corroded, water was going out, and then they had other water coming in from a slide area. The water is re-entering the pipe further down, and that's the water we were seeing coming out of the pipe. So be careful, really investigate what's going on. Because we had to replace the pipe, and if we hadn't done some extra work, we would have left it in place, and it was a mess.
And just another example of some buoyancy forces at work. That's not giving the best level of effort for the picture. See, what that guy could have done was he could come down here and then climb up this way, and then he could like sit up here and dangle his legs over and then
wait.
write his notes.
You could like push on and look like he's like ready with his own strength.
That's not. Oh.
That's gonna get tricky.
All right, so going back to the question, can you have erosion problems at the inlet? Scour at the inlet doesn't really occur frequently enough and is usually not a big deal. Where you get the issues with your soil is if you have a bad approach angle to your culvert. So if you have your channel coming in this way with the culvert over there, then that momentum of the water carries it right into the bank, and that's where all this erosion occurs. So we want to have good alignment of the flow into the barrel whenever possible, and that might mean sometimes skewing the barrel, not putting the barrel perpendicular to your center line, but skewing it so that the opening of the barrel is perpendicular to the flow direction, and the flow's coming at a straight-on angle right into it. Otherwise, you would need to, maybe try to deflect this flow back this way, and you would need to do some slope protection right here. Excessive sediment. We hear about this all the time. Where do you think you could get issues with sediment? And this would be the inlet side. This is just getting plugged up with, this looks like clay, silty type materials, but it also happens with trees and rocks and other things like that. Where are some places where you think that would be of particular concern?
Agricultural areas.
Agricultural areas exactly would be one, yes. Going back and thinking about shear stress and tractive force. It's higher here,
Obviously,
and it's lower here. When you have infrastructure on grade breaks, and especially from steep to mild grade breaks, that water's coming down with a lot of energy, a lot of tractive force. It can carry material, and then if it goes into a very low slope like this, so from kind of like a slope into like a valley area, all of a sudden it's like me right after lunch. All of a sudden its energy level just drops, right? And it doesn't have the tractive force, the ability to carry all that sediment and debris and other things. It just wants to drop it out. And a lot of times we see where we have our culverts and our bridges right at those grade breaks, that's where the stuff's dropping out, and that's where we can have stuff like that happen. Big problem. So what do you do? Well, you need a larger hydraulic opening probably for one, or maybe you need to span the issue, so maybe you don't use a small culvert, or especially not a series of barrels. Maybe you need to have a wider opening from a bridge or something. Your maintenance folks need to know that that might be an area of interest, and they should check on it, especially after flood events. So it's not only a design issue, it's also an operations and maintenance issue. What do we see down here? Head cuts. And do we know what head cuts are? Niagara Falls is kind of like a dramatic example of a very long-term, slow-moving head cut, right? So we had some instability issue downstream, and it caused, some erosion that manifests as this vertical migration or incisional point that continues to move further upstream. If you have a bridge or a culvert right up here, guess what? This is eventually going to come right up to that, and is it going to cause you a problem? Most likely it will. So whenever you're out there, and if you were to be looking more towards streams and channels, but it could also happen in your ditches, don't just look right there at it. Just take a look and maybe take a couple pictures. I'll walk a little way downstream, downslope, and also a little bit upstream and upslope, and look beyond your infrastructure just to see if there are any potential issues doing it. And here's just an example of some slope failure over here. So again, the culvert operates as a system, and we're concerned with the embankment slopes, what's going on in the channel up and downstream as well. Wait a second. Did I just hear that? Isn't this exciting? I'm trying to make this exciting. I'm just kidding. I'm just kidding. All right. Problems can also manifest on the roadway surface, so look at the roadway. If you know you're over a culvert location and you see a crack in the pavement, that may be an issue that your embankment is doing a little bit of settling. If you're driving along and you don't know a culvert's there and you go boom, boom, then you probably know there's a culvert under the road, right? So in that case, there's been some settlement, and if you see that and if you have time, you may want to say, well, do I have any problems within the culvert itself? If it's just a backfill settling a little bit, there's not a lot you can do except for maybe paving over that. But you want to take a look to make sure that there isn't a culvert issue that is contributing to this problem. And Veronica snuck these in here, and actually these are a couple of my favorite pictures. Moral of the story is, whenever you're out on projects, don't go out by yourself. And be aware of your surroundings. And if it's Adopted Pet Week, you may want to take a furry buddy home, or I'm not saying you want a scaly buddy to take home, but that's just a big cat. That big cat would probably like to lie on your couch and watch some TV with you. Listen, you never know, right? Yeah, that's the size. That's probably about 10 McFlys. All right. So we focus mostly on culverts, but the idea extends into your ditch lines, your median ditches, your roadside ditches, your stormwater management practices. I don't know if you use a lot of detention type facilities here. They're kind of hard a lot of times to fit within the right of way. Biofiltration is pretty popular, so if you know that there's some biofiltration, stormwater management facilities within your project, you might want to take a look at those as well. And I don't know if that's a standard practice or not, but it's not a bad idea to do that. Do you have excessive erosion? Is there undermining of the pavement shoulder? That sort of thing. Try to get an idea if there's sufficient capacity, or if the ditch line is eroded, if the vegetation that's supposed to be there is not really there, those types of things. And that may inform what you do with your ditch lining going forward with your project. If what's there is working, if it's not broken, you don't maybe need to fix it. So if it isn't working, then maybe you need to try something else. So just a couple of quick pictures here. What do you notice in this one? Okay. There's deformation right up here, right?
Corrosion at the bottom.
There is corrosion, and you see, this is what we call the spring line. It's kind of the midpoint of the circular culvert. You see corrosion. Well, some of this will be soil staining, but I definitely see some corrosion issues here as well, right? Yeah, so you need to make a decision of, is that good, fair, poor, critical, or whatever rating system you're using, and then give that to whoever can make a decision on whether to do some spot repair, maybe lining, maybe say, well, it's going to be okay for 20 years, or maybe we need to replace it. This is pretty easy, right? This is a smaller culvert, you're not going to crawl inside this, but if this is, regardless of whether this is the inlet or the outlet, if you see rust and corrosion, and if it's not flowing all the time, a little bit of rust or corrosion is not a big deal. Once you start seeing the perforations, though, that becomes a bigger deal, right? So you see some holes and some perforations here. And honestly, if there's not a lot of fill over this, you probably just chalk that up as a replacement. Starting to see the rebar and the concrete's popped out around it, and the rebar's rusty. That to me is probably a pretty serious issue, and it's probably, folks, I don't know if this would be the structures group that would probably need to get involved with something like this. I'm guessing that's probably the case.
So Eric, you only see a tiny bit of light at the end there. Is that because the rest of the pipe is gone?
Yeah, is there, so that's a great question. So that's just using that intuition that we've been talking about. If this culvert is like 300 feet long, then it's probably, yeah, well, it may be just because it's so long. If this culvert's like 50 feet long, we may have a big issue. But if you can, and if this is a person entry situation, you probably want to walk this entire barrel and get an idea of the extent of these types of issues, and if you have any collapse or deformation, right?
It looks like you got a pipe coming off of the side right there, so mine within like an angle.
Is it?
coming in.
Which?
On the right.
There, right next to the red arrow.
Oh, right.
No,
Right.
up
Right
there.
there, right there.
Yeah, so,
That edge of like
and
another-
honestly, I honestly don't know the situation, the context of this picture, but yeah, so there's something, looks, yeah, I think you're right. Maybe something coming in from the side. We already saw this,
Yeah, we
right?
saw that.
Yeah. So again, it's, whenever you're doing these assessments, it's not just the barrel. Look for the aprons, the appurtenances, any scour protection that might have been there in the past, any embankment protection. Look at the embankment itself, look at the roadway surface, look at the up and downstream channels. Yeah, I just threw that in because I thought it was a cool picture. I mean, that's after the fact. I'm not sure what to go into, probably, I honestly don't know. It looked like, I don't know if this was an invert paving that had failed. It looks like this is reinforcing steel, but is that, it doesn't make sense that would be anything related to the initial structural plate pipe here. I don't. And this is just an old picture here that's kind of cool. So here's the Federal Highway guys, here's the manufacturer, here's the inspector.
What is that? Is that a culvert pipe test?
I'd like to see that.
They're just testing it.
Why would you do that otherwise?
They want it in their retirement.
We wanted to show you this sometime before.
There's people down
Yeah.
there inside it.
This is retirement by us.
All right,
They know
so
OSHA regulations back
I
then.
didn't put in the learning outcomes.